So in part 2, what we did was we kept the angle constant. And we varied the mass. And we got a graph that looks like this. Okay, I'm going to move them around here. All right, so what is on our vertical axis here? The acceleration, measured in meters per second squared. And what's on the horizontal axis? The force. And it would have been the net force acting on it, measured in newtons. All right, so now we get an equation that looks like y is equal to negative 0.0025x plus, I'm running out of space, so 1.2367. Okay. Can we say that this right here is approximately 0? All right, so we have almost a 0 slope. And y is acceleration. So acceleration should be equal to, well, if that's 0, then acceleration should be equal to 0.2367 meters per second squared. Now, what? Why is the acceleration constant? We were changing the mass. What happened? Every time you increase the mass, what were you changing? We look at a free body diagram. The gravitational force was going up, so we had the gravitational force. If this is my x-axis, the plane, and this is my y-axis perpendicular to the plane, and I have, what, a normal force that is perpendicular to the plane, and that was all. Your angle of the incline was measured like that. Okay? So then when we sum the forces in the x direction, the only force that has an x component is the weight. And it's negative. It's pointing down the inclined plane. And that component would be Fg sine theta from our notes yesterday. Is it balanced by anything? No. And when we sum our forces and are not balanced, what do we set them equal to? They're not balanced. Like the lab you did yesterday. All right, so we set it equal to ma. This is Newton's second law. Unbalanced forces cause the object to accelerate. Did it accelerate? Did the cart start from rest and move down the inclined plane? It sure did. It sure accelerated. So we have an acceleration. It's not balanced. Now, what about in the y direction? Let's go ahead and look at that. The normal force is up. The y component, Fg cos theta, is into the inclined plane. But are these two balancing each other? Was the object hopping off the inclined plane or sinking into the inclined plane? No. So were the y component forces balanced? And when they're balanced, we set it equal to 0. So let's look at this, because it has acceleration in it. We just came up with an equation that says acceleration equals some constant number. So let's look at that. If I take and grab the equation we just made, so this one right here, and let's just look at it down here, then we've got negative Fg sine of theta is equal to ma. What is the equation for the force of gravity? mg. So we got negative mass times the acceleration due to gravity times sine theta equals ma. What can you algebra ninjas do now? Go grab your favorite, I'll do Mace Windu, a lightsaber, and vroom, vroom. Divide by m on both sides, right? So what are we left with? We're left with negative g sine theta equals a. Why did our acceleration stay around the same number? This is constant. What else was constant? The theta was constant. We didn't change it. So now let's check our work. Again, our numbers. So this would be negative 10. Negative 10. So the acceleration doesn't change. Doesn't matter what the mass is, because the mass canceled out.